Okay, today's topic is all about what we call percent yield. And percent yield, let's talk about first what is yield in a chemical reaction. Basically what we're saying for yield is going to be the amount made in a chemical reaction. So we're looking at the products. You know, everything that's on the right-hand side of the arrow, the products, the amount made. And that amount could be measured in grams, it could be measured in liters. Those are our two typical measurements that we're going to do. We probably wouldn't measure in atoms with respect to a percent yield problem. Now, we have a formula that we're going to use for percent yield, and the formula is given here, and that's percent yield is equal to experimental yield divided by theoretical yield, multiply it by 100 to give it a percentage. That is percent yield. We sometimes also just write it as a percentage sign as well, and so we'll talk about, you know, if you see it like this, percent yield means the same thing, percent yield. Okay, so let's talk about the differences between experimental yield and theoretical yield. That's an important thing to realize. So experimental yield first. Sometimes we call experimental yield actual yield, and it's the amount made of a product and measured in a lab. So if we do a chemical reaction and we form a product and we walk it over to the balance, so we take a measurement, that would be actual or experimental yield, something done in a lab. As opposed to theoretical yield, and theoretical yield is going to be the amount of product we should make. And the way we determine our theoretical yield, and this is super important, is we do the stoichiometry. We do use our Molar to calculate the amount we should have made. Our goal is always going to be as close to 100% yield as possible, but that's the reality of that is that it's usually less than 100%. And there's a lot of different reasons. Some of them are lab techniques, some of them are incomplete reactions where reactions don't do what we think they're going to do. Side reactions might be a little reaction that we don't really realize. There might be some contamination issues. There's a bunch of other issues, but we tend to get less than 100. If we get more than 100, we definitely have done something wrong because we've created matter, and that's not what happens in a regular chem lab. So let's go down here and take a look at a problem that deals with percent yield. So here we go. So we have a balanced equation here. It's already balanced for us, and we're going to identify some things in here. It says, in a lab, a student reacts 23 grams of iron 3 phosphate with excess sodium sulfate. What is the theoretical yield in grams of iron 3 sulfate? So we should be able to identify really quickly here. We have a known quantity of 23 grams. There's our known. And excess, again, means we can ignore the sodium sulfate. We've got plenty to go around. We'll never run out of it. And then we're looking for our theoretical yield in grams of Fe2SO4 3. Okay, so iron 3 sulfate. So remember, theoretical yield means do the stoichiometry. So that's what we're going to do right now. So if you have a Molar, you should probably pull it out. Periodic table, of course. And so we're going to throw in 23 grams as our known FePO4. And we're looking for grams of Fe2SO4 3 iron 3 sulfate. So this is a grams to grams problem that we're going to use on the Molar, and so it's going to be a couple different steps. You've got we know that we're starting at grams, and we know that we're ending at grams. We need to go up the Molar, around the unknown over the known mole ratio, and right back down. Our first step is going to be 1 mole of FePO4 over the molar mass, grams of FePO4. And so in FePO4, just a reminder to you, you have 1 iron. Look that up on the periodic table, 1 phosphorus. Add that together with 4 oxygens. And when I do my math, I get 150.82. 150.82. Okay. So that takes us up to the mole. Again, we're going to do the unknown over the known. Our unknown is over here at our ending. There's our unknown. And so I'm going to slide this guy right in here, and I'm going to put Fe2SO4 3 right there. And right down here, I'm going to put my known. This guy's my known. I'm going to put him on the bottom, FePO4. And remember, these are moles and these are going to be coefficients from our balanced equation. So Fe2SO43 is right there, and it's got a coefficient of 1. And FePO4 is right here, coefficient of 2, so it's a 1 to 2 ratio. And we'll just have to make sure we multiply those two guys on the bottom together when we run this through our calculator. We're going to go back down the road to moles now, or excuse me, to grams now. And it already is telling us here. Okay, so now what's left is to go back down the road to grams, and we have to calculate the molar mass of our ending substance, and that is going to be this iron 3 sulfate. So for this iron 3 sulfate, what we're going to do is we have to make sure that we add together everybody who's in there. We're going to have 2 irons added together. We're going to distribute that 3 through to the parentheses. There's 3 sulfurs. 3 times 4 for oxygen, there's going to be 12 oxygens. And so we're going to add those guys all together in our calculator. And I come up with a really pretty large 399.91 is the molar mass. Okay, so now to run this through my calculator, I'm going to multiply everything across the top, divide everybody on the bottom, and we have a 2 down there, so we can't forget that 2. And the answer that I got in my calculator when I did this correctly, and you should try it as well, is I come up with 30.5 grams of iron 3 sulfate. Okay, so again, we did the stoichiometry here, and so that is going to be equal to my theoretical yield. Now, down here it says if 21 grams of iron 3 sulfate is measured in a lab, what is the percent yield? Well, that 21 grams right there, that is our experimental yield. It was measured in the lab. So what we're going to do to find the percent is we're going to use the percent yield formula. Percent yield is equal to experimental yield over theoretical yield, and we're going to multiply that guy by 100. And so experimental is going to be 21 grams divided by 30.5 grams, which was our theoretical yield calculated from stoichiometry. We multiply this guy by 100, and we get an answer. And so I'm getting an answer of about 68.8%. Okay, that's not too bad. Anything over 60% is pretty decent, and so that lets us know how efficient our reaction is. Now we could have another student do the same thing, and we could compare our percentages, and the one with the highest percentage would be the most efficient reaction. Okay, and that is how we calculate percent yield.